You are buying concert tickets, you hit pay now, the page spins for 10 seconds, then shows an error. You check your bank, the money is gone. You hit pay again, now it's gone twice. The first charge went through, the error was network timeout and the response not on the payment itself. Your Lambda ran, Stripe charged the card, but the reply never made it back to the client. So the user retried, and your Lambda had no idea it had already done this. That's exactly the idempotency problem. And it's not a niche edge case. If you are building anything on AWS that handles money, sends emails, updates records, or triggers downstream actions, that is happening in your systems right now. That isn't hypothetical. On June 26, 2023, Cash App users woke up to their accounts in the red. Nobody had been hacked, nobody made a mistake. Cash App had silently charged them twice for the same transaction, at scale. Support lines went down at the same time, leaving users watching their balances go negative with no way to reach to anyone. Cash App's only public statement was a tweet. We recently discovered a technical issue that led to some customers getting charged double the amount of the certain cash card transactions. Our team is aware of the issue causing duplicate cash card transactions, which is making some customers see a negative account balance. We also know that in-app and phone support is down. We are looking into these matters. A technical issue. That's it. They never disclose the root cause, but the symptoms are unmistakable. A transaction processed twice from a retry that wasn't deduplicated. This is what idempotency failures look like in production at a company with a large engineering team on a Tuesday morning. Last video we covered retry strategies. Retries are actually the main reason idempotency matters, because every retry is a potential duplicate call. So if you haven't watched that one, link is in the description. Today we are going to understand the problem from the first principles, and then I'll show you how to implement a solid solution using DynamoDB conditional writes. Let's get started. Let's start with what idempotency actually means in practice, because the formal definition is not very useful. The practical definition is this: calling the same operation multiple times produces exactly the same result as calling it once. That's it. If you call it once or 100 times, the outcome is identical. Here's the clearest way to see the difference. Imagine a database operation that sets a user's balance. You can run that 1,000 times, the balance is 100 every single time. That's idempotent. Now compare it to this. Run this 1,000 times and you've added 10,000 to the balance. That's not idempotent. The result depends on how many times it ran. The key insight is that you can't prevent duplicate calls in a distributed system. Networks retry, queues redeliver, users double-click, step functions reinvokes. You do not control this, so your code must handle that. Let me show you specifically where duplicates enter your system on AWS, because it's more places than most people realize. Lambda's at least once execution guarantee. AWS Lambda guarantees your function will run at least once, not exactly once, at least once. Under certain conditions, particularly with asynchronous invocations, it may run twice for a single event. SQS standard queues. Standard SQS queues guarantee at least once delivery, not exactly once. The same message can be delivered more than once, especially under high load during infrastructure events. SQS FIFO queues give you exactly once processing with a deduplication window, but only if you're using them correctly. API gateway plus Lambda on 500 errors. If your Lambda returns a 500, API gateway may retry the request, the client may also retry. Now you have the same request hitting your Lambda multiple times. Steps functions retry configuration. We covered this in the last video. Step functions has its own retry configuration separate from the SDK. If a Lambda task fails and step functions retries it, your Lambda runs again with the same input. And finally, client-side retries. Calling service twice, whether it's another Lambda or mobile application or front-end, will retry failed requests, with exponential backoff and jitter as we discussed. From the receiving end, you can't tell a retry from a new request. The pattern to internalize is this. Any retry mechanism is a duplicate source, and there are a lot of retry mechanisms. The solution is Idempotency Key Pattern. It's conceptually simple. Every mutating request, anything that creates, updates, or deletes, carries a unique identifier called an idempotency key. When your service receives a request, before doing anything, it checks whether it has seen this key before. If it has seen that, return the stored result from the last time. Don't process it again. If it hasn't, process the request, store the result, and return it. That's the whole pattern. The key usually comes from the caller they generate before sending the request. This is how Stripe works, how Twilio works, how most well-designed payment APIs work. So the caller is responsible for generating a unique key per logical operation. In AWS, you can also pull the keys from the infrastructure itself. SQS use message ID, it's unique per message. API gateway, use the request ID from the request context. Step functions, use the execution ID. Event bridge, use the event ID. The important thing is that the key must be unique per logical operation, not per request. A retry of the same operation must use the same key. A new different operation must use a different key. And how to differentiate operations is your role when you're writing code. Now let's build this. I want to start with the wrong way because it's the approach most people start with first. So the naive approach, we first check, then act. You check DynamoDB to see if the key exists. If it doesn't, you process. If it does, you return the cached result. It all looks fine, though it's a race condition. Two identical requests arrive at the same millisecond, both check DynamoDB, both see the key doesn't exist, both process the request, both write the result. And now you executed the operation twice. Under normal traffic, certainly this will never happen, but under retry storms, it happens constantly. The correct approach here is to utilize atomic conditional write. DynamoDB conditional expressions let you make a write conditional on the state of the item at the moment of writing atomically. No separate read is required. The condition we want is only write this item if the idempotency key does not already exist. The attribute not exists condition check, and the write happens as a single atomic operation inside DynamoDB table. There's no window between them. Two concurrent requests with the same key, one wins and another gets conditional check failed exception. In that case, it reads the stored result and returns it, no double processing. Also, a quick note on TTL. Always use TTL on your idempotency records. You don't need to store this forever. Typically, 24 hours is more than enough to recover any reasonable retry window. Without a TTL, your idempotency table grows indefinitely. DynamoDB TTL deletion is asynchronous, and that's fine. Expired items stop being reliable immediately. And the definition of immediately can be different for any system, so you must figure it out yourself. AWS Lambda Powertools has built-in idempotency module that handles all of this for you. The conditional write, in progress status, timeout window, the TTL, all behind a decorator. You can see an example on the screen. The decorator intercepts the invocation, checks the idempotency key in the event, handles the DynamoDB conditional write, manages in progress state and timeouts, and returns cached results on duplicates. Use Power Tools if you're already using it for other utilities. You don't need custom key extraction logic, and if you want to move fast. If you want, you can roll out your own and do that if you need fine-grained control over what gets stored and custom key sources, or you're working in a language Power Tool doesn't support well. Let me run through the mistakes I see most often. Using a non-unique key. The most common one. Using a timestamp as the idempotency key. Two requests in the same millisecond get the same key. Use UUID, or better, use the infrastructure provided IDs that we mentioned. SQS message ID, API gateway request ID. Not storing the response. Your idempotency record needs to store the actual response, not the fact that you processed it. If a duplicate arrives and you return to 100 with the empty body or a generic already processed message, you've broken the contract. The caller needs the original response. Idempotency at the wrong layer. You make your Lambda idempotent, but your Lambda calls Stripe with a charge request, and that call to Stripe is not idempotent. You've only solved half of the problem. Idempotency needs to go all the way down. Not setting a TTL. Your idempotency table will grow without bound. Every operation you've ever ran is stored forever. Set a TTL. 24 hours is a good starting point, making it optional. We'll add idempotency if we see issues in production. By then, you've already charged someone twice. Build it in from the starting point on any operation that has side effects. So here's your checklist before shipping any mutating operation. 1. Does every request carry an idempotency key? And is the key unique per logical operation? 2. Is your check and write atomic? 3. Are you storing the full response? 4. Do your records have a TTL? 5. Is idempotency implemented all the way down to your downstream calls, not just at the Lambda layer? If you can check all 5, you are safe to retry. That's it for now. See you in the next video. Bye.